So physics has a lot of measurements in it. There's a lot of measuring of how fast things are moving, how quickly things are speeding up and slowing down, how far away things are, how much heavier or lighter things are getting. And so today we're going to talk about how do scientists measure some of these different types of measurements. And they're a little bit different than the measurements that you might be used to if you grew up in the United States. So in science, when scientists are doing their experiments and taking their observations, all scientists across the world use the same system of measurements, what are known as the standard units or the SI units. And so these are a little bit different than the units that we normally use in the United States. So in the US, we have things like gallons and pounds and feet and miles. But all scientists around the world use a different system of measurements that a lot of other places use as kind of like their default, which can be called SI units, which stands for like standard units, but more commonly, it's referred to as the metric system. So if you're a scientist in America or Canada or China or South Africa or Egypt, you're using the metric system in order to measure and take down your observations. And so today we're going to talk about what is the metric system, what makes it a little bit different from the English system or the American system. And we're especially going to talk about how we can change between big and small metric units or metric measurements. So there's three major types of measurements that scientists make. There is length and distance, there is mass, which is weight, and there is volume, how much space that something takes up. And so the first one that we're going to talk about today is length. So how wide or how tall something is, how far away something is, it all falls under length. So in America, we have things like inches and yards and miles and feet. In the metric system and the SI system, they have meters. So 1 meter is approximately the same as 1 yard. It's a little bit longer than a yard. There's also kilometers, which are the larger size. 1 mile is about 1.5 kilometers. And then 1 inch for the smaller side, instead of inches, it's about 2.54 centimeters. So meters, kilometers, centimeters, these are how scientists and how most people around the world measure things like length and height and distance. So the base unit for length is called the meter. So everything else is kind of based around the meter. So the way that we usually represent a meter is with a little lowercase m. So if you see something that's like 7m or 14m, that stands for 7 meters or 14 meters. Just like IN stands for inch or MI usually stands for miles. In this case, meter is usually abbreviated as M. So a meter is our base unit. And if we go bigger than that, we have kilometers. So a kilometer is 1,000 meters. You take 1,000 of those meter sticks and stack them end on end on end with each other. And at the very tip, they all reach out to 1 kilometer long. So km for kilometer. Kilo means like 1,000, essentially. You can also go on the smaller side of a meter. So if you took a meter and split it up into 100 pieces, each piece would be 1 centimeter long. So 100 centimeters together makes a meter. And we can also go even smaller than that. So 1,000 millimeters together makes 1 meter. So if we go back and look at that kind of little picture of the ruler that we were looking at a second ago, here are our inches up top. So 1, 2, 3 inches. Down here, the big numbers are the centimeters. So if you follow this 1, 2, 3, 4, 5, 6, all the way up to 100, then you'd have 1 meter. But there's also these tiny little lines down here, and these are our millimeters. So there are 10 millimeters in a single centimeter. And then if we put 1,000 of these little millimeters together, we would end up with 1 meter. So that's one of the things that scientists really, really like about the metric system, is that all of the different sizes are all based around the base of 10 or 100 or 1,000, which is really, really, really easy to kind of convert between in a way that we'll talk about in a little bit. So instead of being like our kind of weird American system of 12 inches is a foot, and then 3 feet is a yard, and then 1,300 something yards is a mile, or 5,200 something feet is a mile. All those are kind of weird random numbers. And the metric system and the SI system, it's all based around tens, hundreds, and thousands. So we have our meter. 1,000 of them becomes a kilometer. If we have a centimeter, 100 of them becomes a meter. And if we have a millimeter, 1,000 of them becomes a meter. So meter is our base unit, and it's our base unit for when we're talking about length, how long or how far away something is. The next type of measurement that scientists make has to do with the mass of something. Essentially, how much stuff is there? What is the weight of this object? So when you see mass, think like weight. Like if you put this thing on a scale, how much would it weigh? That is its mass. So in our American system, we have things like pounds and ounces and tons if you get really, really, really big. On the metric side, we have things like grams and milligrams and kilograms. So again, same kind of system like in the meters where we have our grams, and then we also have kilograms, which are bigger, and milligrams, which are smaller. So a kilogram is about 2.2 pounds. So if somebody weighed 220 pounds, they'd weigh about 100 kilograms. And then 1 pound is about 450 or so grams. So a gram is pretty small and light, and a kilogram is relatively hefty. So mass refers to how much matter is in an object. Essentially, how much does it weigh here on Earth? And our base unit is the gram, or the little g. So just like with our meters, if we put 1,000 grams together, that'll give us 1 kilogram. And if we split something that was weighed 1 gram up into 1,000 equal pieces, each piece would weigh 1 milligram. So if we put 1,000 milligrams together, we get a gram. Put 1,000 grams together, you get a kilogram. So a gram is really, really small and light in terms of its weight. So think about the weight of like a paper clip or like a single like dime or penny coin would probably weigh about 1 gram. Like this pen right here is probably like 10 or 15 grams if I had to guess. So gram is pretty small. Kilogram, on the other hand, obviously there's 1,000 of them, so it gets pretty hefty. It's a little over 2 pounds. And so I don't know why, maybe because I'm a teacher and so I'm surrounded by these books all the time. But like a big school textbook is what I kind of think of as weighing about 1 kilogram. So like your big like math or science book, or like like an old school dictionary at the library, or like one of the like encyclopedia books, those would be about a kilogram. So pretty hefty for a single unit. And then on the other side, milligrams are incredibly small and tiny. So in the tiny little tablets of things like pain medicine that you might take, like Tylenol or Advil, something like that, it can be anywhere from like 10 to 50 to 100 to 300 milligrams of the medicine in that tiny little capsule. So milligram, very, 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 very small. Gram, still pretty small and light. And then kilogram is relatively hefty. But again, this is for mass, for the weight of something. So gram is the base unit, and then you go bigger, you get kilogram. You go smaller, you get milligram. Finally, the last one that we're going to talk about in terms of the different measurements is volume. So volume is like how much space that something takes up. So how overall large is something? How much area does this object take up? So in the English or American system, we might measure liquid volume with things like gallons or quarts or pints or ounces or cups. In the metric system, get rid of all that, and we have liters and milliliters. So a single liter is really, really close to a quart. So a quart is like a quarter of a gallon. And so some things that you buy at the grocery store that come in quarts would be like certain types of milk, or I always think about eggnog that you get at like the holiday times. It comes in a really tall, skinny carton. That is a quart of liquid. So that's about 1 liter. You can also, actually, liters are probably one of the few things that you can pretty readily find in the supermarket, because the big soda bottles, like a big bottle of Coke or Pepsi or Dr. Pepper or something, the really big ones are 2-liter bottles. They're called that because they contain 2 liters of liquid, 2 liters of volume. So 1 liter is really close to a quart. So a little over 3.5 liters is 1 gallon. So volume, how much space an object takes up. So our base unit is called the liter, and it's represented by a lowercase l or a capital L. I personally like using the big L just because that helps it be clear that it's not a 1, it's an L, because sometimes L's and 1s can look pretty similar. Another way that we can measure volume is something called cubic centimeter. So this would be for like solid volume, so the volume of like this cube right here. Instead of measuring it in milliliters or liters, we can measure the sides in centimeters and figure out the cubic centimeters. What is its overall area when we combine height, width, and length? So cubic centimeters, this little CM3, is another way of showing off volume. So just like with all our other ones, liter is our base unit, and then we have smaller units of milliliters or ml. Again, I like using the big L because it makes it clear it's an L and not something else. So 1 liter is 1,000 milliliters. So 1,000 little individual droplets go into making up 1 liter. Like I was saying earlier, a liter is sort of like the medium-sized soda bottle, and then the 2 liters is like the bigger one that you get for parties and stuff. And then milliliters are obviously, there's 1,000 of them in there, so they're pretty small. I usually think about like a raindrop or a single droplet out of like an eyedropper bottle. That would be approximately 1 milliliter. So we're not using gallons or cups or teaspoons or ounces. We're using liters and milliliters, L's and mL's. And 1,000 milliliters altogether makes up 1 liter. All right, so we've got our length measurements of meters, and then we can have kilometers that are bigger, and centimeters and millimeters that are smaller. We have our weight measurements of grams, and then we can have kilograms, which are bigger, or milligrams, which are smaller. And then finally, for our volume measurements, we have liters, where we have our normal base liter, or our smaller milliliters. And these are what all scientists across the world use, whether you're in China or Japan or India or Iran or Nigeria or Germany or England or America or Canada or Mexico. All scientists use this metric system, this standard international system. It makes it easier to talk to other scientists around the world. And the fact that all of the measurements are based on tens and hundreds and thousands makes the different numbers really, really easy to deal with and convert between, which is why scientists like it as well. All right. Any questions about meters, grams, or liters before we move on?
Not so far.
No.
All right, cool. So that was sort of the little introductory piece to kind of introduce what some of these new different measurements are. And so the next thing that we're going to talk about is how to convert between the different sizes. So if you're going from bigger to smaller or smaller to bigger, how can you change your meters into kilometers or your milligrams into grams? And so luckily, the fact that it's all based on these tens and hundreds and thousands means that it's really, really easy to do once you get the hang of it. And so somebody developed this really useful ladder method that I liked a lot, that I'm going to show you guys how to use it to easily convert between our different sizes of unit. So the way it works looks kind of like this. So here is our ladder, what's called the unit ladder. So we have our kilo, our big size up here. We have our milli and our centi, our little sizes, over here on the right. And then right in the middle here is the basic unit. So depending on what we're talking about, this could be a meter, this could be grams, or this could be liters. But any of these guys are our basic units of measurement. So if you're trying to convert between different sizes of unit, there are a couple steps that you can follow using this ladder in order to easily go from one to the other. So the first thing that we have to do is figure out our starting points and our ending points. So let's kind of work through this example over here, kind of step by step. So let's say I have 4 kilometers, km, that's what that stands for. And I want to convert these 4 kilometers into meters. I want to know how many meters I'm going to have if I have 4 kilometers. So our starting point is our kilometers, which is up here in the kilo box, kilo step. Ending point is meters, which is our basic unit, right? Meters, one of our basic units right here. So starting, ending. All right, got that figured out. Next step. We're going to jump from the starting point to the ending point, hitting each one of these boxes in between. So these other guys that are in here that we haven't really talked about yet, they're kind of lesser used measurements. Scientists don't really use them at all when they are measuring volume or length or mass. So we're not really going to talk about deci or deca or hecto. We're going to be all focused in on kilo, centi, and milli. The reason why they're in here is that they're still steps on this unit ladder. So if we're starting at kilo and we're going to meter, our base, we're gonna make some jumps in order to get there. So in this case, we're gonna follow this little red line that's already been put here for us, and we're gonna go 1, 2, 3 jumps to the right. So the direction is also important. So we have to keep that in our mind as well. So how many jumps and what direction? In the case of kilo to meter, we're going 1, 2, 3 jumps to the right. All right, so that's step 2. Final step is to go back to our number that we're dealing with, in this case, 4. Take the decimal point of that number and move it the same number of jumps in the same direction. Whoops. So going from kilo to meter was 1, 2, 3 jumps to the right. So we're going to move the decimal point here 3 jumps to the right. So that's what's going on in our little example down here. We start off with the decimal right after the 4. And sorry, this little thing is popping up and covering the bottom here. But our first decimal is right after the 4 right here. And then we're going to move this guy 1, 2, 3 jumps to the right, just like we did up here. 1, 2, 3 to the right. 1, 2, 3 to the right. So now our decimal point is over here, which means that all these empty spaces in the middle are going to be filled in with zeros. So we have 1 empty space, 2 empty space, 3 empty spaces. So we're going to put 3 zeros after our 4. So our new result is we start off with 4 kilometers. That means that we have 4,000 meters. So that decimal point used to be right here, but it jumped 1, 2, 3 jumps to the right. Now it's over here, which you can't see it because I left it off because it doesn't need to be there if there's not a decimal number there. But it's hanging out over here, and we filled in all these spaces in between with zeros. So 4 kilometers is 4,000 meters. We jumped that decimal spot 3 jumps to the right and filled in with 3 zeros. 1, 2, 3 zeros, giving us 4,000. So we will definitely do a lot more examples of these to make sure everybody's kind of on the same page. But does anybody have any initial questions? Anything about this that you're still super confused about or not really sure how we got 4,000 from our 4?
No.
No.
All right. Everybody seems kind of okay with this so far. So let's look at some more examples. So let's see here. Let's start off with this one because it's pretty simple and straightforward. This says that 1,000 milligrams is equal to 1 gram. So I'm not sure about that. I want to check and make sure this is right. So we're starting off with milligrams. So milli is over here. And we're going to grams. And remember, grams are one of our basic units. They're in there with the meters and the liters. So we're going milligrams to grams over here. So we're going to the left. And in order to get from milligrams to grams, we're going to go 1, 2, 3 jumps to the left. So if our decimal was right here, we'd go 1, 2, 3 jumps to the left. Now, instead of having 1,000 milligrams, we have 1.000 grams, which is the same thing as 1. So 1,000 milligrams is in fact equal to 1 gram. I moved that decimal 3 spots to the left, and it went right after that 1. All right, let me look at another good example here. Oh, this one I like. Let's see, we have 160 centimeters, and I want to know, is that really equal to 1,600 millimeters? So centimeters, centi is right here. So that's our starting spot. And millimeters is our ending spot over here. So these guys are right next to each other. So if we start at centimeters, we're going to make 1 jump to the right to millimeters. So 1 jump to the right is where we go from start to end. So the decimal point was right here at 160. If I move it 1 more to the right, fill in that 0 right here. Now, instead of being 160, it is 1,600. So the decimal was right after 160, but if we move it 1 more spot over, it becomes 1,600. So 160 centimeters is, in fact, 1,600 millimeters. All right, I'm going to do 1 more for you guys on my own, and then we're going to do a couple examples together to kind of really make sure that everybody's got it down. So let's look at this last one here. This is telling me that 250 meters is equal to 0.250 kilometers. So to check if that is right, we're going to start with, let's see, meters is one of our base units. So we'll start here. And kilometers is over here. So starting with our base, ending with kilometers. How do we get there? Well, we've got to go 1, 2, 3 jumps to the left. So I started with 250. If I take that decimal point 1, 2, 3 jumps to the left. Now I don't have 250 anymore. I have 0.250. So it is, in fact, if we go 1, 2, 3 to the left, 0.250 kilometers is the same thing as 250 meters. So figure out starting point, figure out ending point, count the jumps and direction between them, and then do that same thing with the decimal place on your number that you're interested in. All right, so we're going to do some more examples kind of together as a group in just a second. But does anybody have any questions before we go into that? Anything that still you're not 100% sure about or isn't making 100% sense?
No, thank you.
All right. So in order to work on some of the more examples together, I'm going to bring up a new whiteboard. Actually, it's an old whiteboard because it's one that I am using that's left over from my earlier IPC class. I'll put the link in the chat if anybody is interested in joining it on their own, but I'll also present it here. All right, sorry about all the random little bits and bobs that are around. Those are some leftovers from earlier. So here is my very, where's my mouth? There it is. Here is my very rough interpretation of our ladder. It has all the really important parts that you need to know. We've got our kilo, our base units of meters, grams, and liters, our centi, and our milli. So let me find a good example to start with. Let's see here. Ooh, that's a really good one. All right. So I have 65 grams. And I want to know how many milligrams is that? So we've got grams, and I want to convert these grams into milligrams. So first things first, I'm going to have you guys help me out a little bit on this one. Where is my starting point? Where am I going to start on our ladder here?
With the M?
With this M?
Yes.
Yeah.
So is this our starting point or our ending point?
No, That's the ending point.
We're gonna start
Oh.
the
Like the
gram.
base.
Gram.
Mhm. So yeah, the milligrams, the milli is what we are ending with. That's what we're going to. So milligrams is going to be our end point right here. All right, end right there.
Do we start with the kilograms?
So our starting
Oh,
unit,
from the gram, the basic.
the base, yeah. So gram
Oh,
is
yeah,
one
the
of our
basic.
base units. Right, so right here is going to be where we start.
So, Mr. Michael, I'm just confusing about the base. So the base are like kilogram, right? The gram and
So the base is for meters or grams or liters. So those are our base units. All right, so the K would be for kilograms or kilometers. The C would be for centimeters. And the M would be for milligrams or milliliters or millimeters. So anything that starts with milli is going to be the M. Anything that starts with centi is going to be the C. Anything that starts with kilo is going to be the K. And all the other ones, all the ones that don't have that special starting prefix are our base units. All right, good question. So gram is one of our base units. So that's the starting point right here. Milligram is what we're going to. So that is our ending point down here. So what direction are we going to travel to go from grams to milligrams? Left or right?
Right.
Right?
Correct. So we're going to go here and here and here. So how many steps is that from base to milligram?
3.
3.
Three steps. So with our $65, the decimal starts right here. And then we're going to go 1, 2, 3 spots to the right. We jump 3 spots to the right. So now we go 1, 2, 3 spots to the right. And then what number is it that goes in these blank spots right here?
0.
0. Man, you guys are good at this already. So we start off with 65 grams. And we ended up with 65000, which is 65,000 milligrams. So 65 grams is the same thing as 65,000 milligrams. Started with grams, 3 jumps to the right for milligrams. So we moved our decimal spot 3 jumps to the right. Ended up putting 3 zeros in. So we went from 65 to 65,000. All right, very good, very nice.
Mr. Mike, can you please just leave it like a second? I just want to
Sure.
write. Thank you.
So we got our ending point right here. All right, while you're looking at that, let me go find another good example. What was it really? Oh, yeah.
Yes, I'm good now. Thank you.
Cool, no problem. All right, so get rid of some of this guy. And then get rid of this, and oops. There we go. All right, up next. Actually, I can leave that 5 right there for now. Oh, there we go. All right. So next problem we're going to work on. We're going to start off with 75 milliliters. And we're going to convert that into liters. So we're starting off with 75 milliliters. And I want to know how many liters is that? So first thing we got to do, what is our starting point on the ladder?
The M.
M.
The M.
Our little M for milli over here. This is where we're going to start. And then what about our ending point? What is our final product going to be?
In the base?
Base.
In the base.
Yeah, Andrea's got it, the base. So I'm just going to write E for end. So liters is one of our base units. And so if we're ending with liters, our ending spot is going to be our base. So starting with milliliters, ending with liters, what direction are we going to be jumping?
Left.
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 To the left. And how many jumps are we going to make to the left?
3.
3.
A.
3. 1, 2, 3 jumps to the left. All right, very cool. So actually, I can just do it right here. So we started off with our decimal point right here. So we're going to jump 1, 2, 3. There we go. 3 spots to the left. So our new decimal is going to be over here. And what do we put in an empty spot, a blank spot?
Zeros.
A 0.
So what is our 75 milliliters equal to?
0.075 milliliters.
Yep. 0.075 liters. So 75 milliliters is the same thing as 0.075 liters. Again, followed all of our steps, started at milliliters, ended at liters. We figured out it was 3 jumps to the left. So we did those 3 jumps. We had an empty spot, so we had to put the 0 in there. So our 75 after those jumps became 0.075. So that is how many liters are in 75 milliliters. All right, very, very cool. Very awesome job with that so far. Let me find one more good example for you guys. Let's see. I think that'll be good. All right. Gonna get, oops, that's okay. This and all right. So we are going to start off with 198 grams. And I want to know what is that measurement if you converted it to kilograms. So 198 grams to kilograms. So where are we going to start on the ladder?
Base
The
point.
base.
The base.
At the base. Grams is a base unit, so we're going to start with an S at the start of our base. Where are we going to end? What's our ending point on the ladder?
Kilogram.
Kilograms. Okay.
Kilogram. Kilo is K. So up here is our ending point. So we're starting off with our base. We're ending at K, kilograms. So which direction do we have to jump in order to get to kilo from the base?
Right.
Yeah.
Left.
Left. Going from the start, left to the end. And how many jumps are we going to make?
3.
3.
3. There's that 3 again. 1, 2, 3 jumps to the left to go from base to kilo. So our decimal point starts right here. We're going to go 1, 2, 3 to the left. So we start off with 198 grams, but what is that in kilograms?
It's a 0.198.
Exactly. 0.198 kilograms. So our decimal point started right here, but it jumped 3 spaces to the left and ended up here in front of the 1. So 198 grams is equal to 0.198 kilograms. All right. Awesome, awesome, awesome. Very good job, everyone. Does anybody have any final questions about these conversions? Anything about these that you're still a little bit confused about or not sure about where we're going?
No.
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 So, Mr. Michael, this one we just work on it. That's the one we're gonna always use to convert all the time.
Mm-hmm. Yeah, with the ladder. Yeah.
Okay. Thank you.
So I posted, I'll show you guys in a second, but I posted a picture or a slide of just the ladder in the Google Classroom on the notes section if you want to go take a look at that. So, hold on, there we go. Okay. There we go. I think we did some. Oh, the only other thing that I want to mention is that most of the time you're dealing with whole numbers like these ones. So in this case, like on this one, the decimal point was at the very end. Sometimes they show you exactly where the decimal is because it's part of the number. So like right here, we have 5.6 kilograms. So when we started our conversion, we'd start right here with the point, and then kilograms to grams is 3 jumps to the right. So it would go 1 and then 2, 3, which would be 2 more zeros. So it moved the decimal point 3 to the right from where it's at. Like same thing with this one. Centimeters to millimeters is 1 jump to the right. And so the decimal point started right here. And then it got moved 1 jump to the right over here to go from 6.3 to 63. Just wanted to point that out because I know it's not an example that we went over just then. So that is how you use the ladder right here in order to convert between the basic units, the millis, the centis, and the kilos. You determine your starting and ending points. You count how many jumps and in which direction you have to go in order to get from the start to the end. And then you move your decimal point, that number of jumps in that direction. So like I said, also in these Tuesday notes section of the Google Classroom, I also posted a handout of just the units ladder if you want to go and look at that for your homework tomorrow. So your assignments on this, the first one for today just has to do with the actual units themselves. So there are a couple different sections. The first one is I give you the abbreviation for the unit, and I want you to tell me, does this refer to a unit of length, a unit of mass, a unit of time, which we didn't really talk about in the notes today, but that's because time works the same all over the world with S for seconds, min for minutes, and H or HR for hours. So you might see like some seconds or some minutes thrown in here, but all the other ones are going to be like mLs or kgs or m's or cms. And so for each one of these, I want you to tell me, is it length, mass, time, or volume? The second part is I have the whole name of the unit written out, and I want you to tell me the symbol or the abbreviation for the measurement. So like which one of these is cm, which one is kg, which one is L, so on and so forth. And then finally, the last piece down here is that I want you to use these units that we've been talking about and kind of apply them to these everyday situation. So which unit best represents the size of a soda bottle? Which one best represents how long a housefly is? Which one represents about how long you can stretch your arms out? So you're going to fill in these blanks here with the unit of length, width, or length, volume, mass, or time that best fits. So that is the assignment for today. And then Wednesday, so tomorrow's assignment is all about those conversions that we were just doing. So it's a whole bunch of different examples where I give you a starting value and I want you to tell me the ending value. So how many grams are in 1,000 milligrams? How many kilometers are 250 meters? How many meters are 480 centimeters? How many milliliters are 5 liters? So on and so forth. So there are a lot of them, but they're all the same basic setup that we were just doing. Using the ladder and converting, making those jumps going from one to the other. So figuring out your start and end point, count the jumps in the direction, and then move the decimal place the correct number of spots, filling in any empty spots with a 0. All right, so those are your assignments for today and tomorrow. Does anybody have any questions on these homeworks or the notes that we went over earlier or anything that we've talked about with these SI units so far today?
Is tomorrow's homework already posted?
Nope. Tomorrow's homework will be posted at the beginning of the day tomorrow.